All right, guys, 7.2 is all about graphing quadratic functions, particularly when they are written in what's called vertex form. You don't need to worry too much about that language right now. It's going to matter a little bit more in Unit 8 because quadratics can be presented in lots of different forms. Today, they're all going to look pretty much like this parent function right here. F of x equals x squared is the parent function for the quadratic functions. When you look at what that looks like when it's graphed, we've talked about this in previous chapters, but the quadratic function, that x squared, gives you that U-shaped graph. Now, just like the absolute value functions, that U-shaped graph, if there's nothing happening to x squared, it's just right there in the center and it looks pretty normal. But if I start manipulating x, if I add numbers to x, if I multiply numbers by x, if I add numbers after I square x, that's going to take that U and it's going to move it. It's going to shrink it. It's going to stretch it. It's going to flip it upside down. It's going to manipulate what the function looks like. However, if this is a x squared function, it will still have the general shape of a U. Just like linear functions are always lines, they're not always the exact same line, but they're always in that same general shape. The quadratic functions are always going to be the general U-shaped function. All right, so moving over here to the right, this is what we call vertex form of a quadratic. F of x is the name of the function. The x squared, you don't notice it as much because the x is inside these parentheses, but the x squared is right there. It's just the x part of it is in the function or in the parentheses. So the nice thing about the rules that you learned with absolute value functions is they are exactly the same as with quadratic functions. This number on the inside of the parentheses with the x is going to give you the x value of the vertex. This is going to shift left and right. The k on the outside of the parentheses that's getting added after the square is going to shift up and down. And the a in front is going to stretch. It's going to either make your parabola this tall, skinny parabola, or it's going to make it this fat, wide parabola. All right, so let's maybe add that to our notes. The h is going to shift left or right. And remember, it goes in the opposite direction. So a negative number where the h is at is actually going to shift it to the right. So you might want to write shift left or right in the opposite direction. Okay. Now k is going to shift your function up or down. If it's a +5, your function goes up 5. If it's a -8, your function is shifted down 8. Which means that hk is your vertex, just like the absolute value functions. And now a. A is a little bit funny in a quadratic function. A positive a value opens up. A negative a value is going to be a parabola flipped upside down. So it's going to look more, it's going to be an upside down U. But the a, the number itself, is going to stretch, or we use the word compress the parabola. Now, if it's a number bigger than 1, so if a is bigger than 1, it's going to be stretched and it's going to be skinny. If a is less than 1, so if a is a fraction like 1/2 or 3/4 or 1/3, if a is less than 1, then it's going to be compressed and it's going to be fat and wide. All right. All right, moving on. You know what? Let's not move on. Let's start with that. We'll come back to domain and range here in a minute. So if I go down to example, we're going to skip example A. We're going to look at example B. It gives me a function, f of x equals x plus 2 squared. I'm just reading right here, minus 3. Now this minus 3 tells me that my parabola, instead of being right at 0, 0, is shifted down 1, 2, 3. This plus 2 on the inside tells me that my function is not going to be right in the middle. It's going to be shifted 1, 2 to the left. So this tells me to go left 2. This tells me to go down 3. So I'm going to go left 2, down 3, and I'm going to put a dot. That is the bottom of my u. From there, my function is pretty normal. It's normal shaped, and a normal parabola, and this is something we maybe need to add to our notes up above, a normal parabola goes up 1 over 1, and then from there, it goes up 1 over, it's going to go, let's see, we're going to go up 3, 1, 2, 3, and go over 1, because our function is growing exponentially. So it's going to get steeper as it goes. It's not going to go up 1 over 1 every time. It's going to go up 1 over 1, but then it's going to go over 2, up 4 on the second one. So that gives you your U shape. Now the second example, that negative 1 on the inside tells me that I'm going to shift to the right 1, and there's no number over here. So that means I don't go up, I don't shift up or down at all. That just means I'm shifted to the right 1. So there's my vertex right there. And then the negative in front tells me that my parabola is upside down. So when I go over 1, I'm not going to go up 1. I'm going to go over 1, down 1, and put 2 dots. And then I'm going to go over 2, and I'm going to go down 1, 2, 3, 4. Over 2, down 1, 2, 3, 4. So it's an upside down parabola. Now, the next one, there's a 2 in front of the x squared. There's no number inside parentheses with the x, but there is a minus 4 that comes after the x squared. So that means that minus 4 tells me that I'm going to go down 4. And that 2 out in front is my a, right? That 2 right there is a. And I'm going to show you how that changes our graphing a little bit. So my vertex is not shifted left or right at all. It's just down 4. Now, instead of going over 1, up 1, my new value is over 1, up 2, because a is 2. So I'm going to go over 1, up 2. Then I'm going to go over 2, and this time I'm going to go up 4 times a. 4 times 2 is 8. So I'm going to go over 1, 2, and I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to do the same thing to the left. Left 1, up 2, left 2, up 8. So this parabola is a lot skinnier than those other parabolas because that a value is bigger than 1. All right, now, domain and range. Something to remind you, because it's probably been a while since you've seen domain and range. Now, the domain is how far left and how far right your function exists, okay? So if I have a graph of a line, my line goes to the left and the right forever. So my domain is something like negative infinity, comma infinity, because it goes to the left forever and it goes to the right forever. Okay? If I don't have a line, if I had something different, if I had a different shape, like a, I don't know, let's just say my function is a rectangle. And this value right here is -4, and this value right here is +4. Well, my function goes to the left, but it only goes to the left until I get to -4. And then it only goes to the right to positive 4. So my domain isn't infinity to infinity. Actually, because it reaches the 4s, I should use brackets, right? My domain stops at negative 4 and it stops at positive 4. Now, range is the up and the down. It's how far up your function goes and how far down your function goes. In this case, I haven't given these a value. Let's say that this is 6 and this is negative 2. So my range, I start with my lowest number. It goes down to negative 2 and it goes up to 6. Okay? If this was a line, then my range would be negative infinity to infinity because it goes up and down forever, right? We call these different, this notation is called interval notation. It tells you the starting point and the ending point. The number on the left is where you start. The number on the right is where you end, right? So a couple examples about interval notation, going back to regular number lines. If this was my number line and it wanted me to write it in interval notation, the number furthest to the left is negative 2. The number furthest to the right is positive 3. So my interval notation would be from negative 2 to positive 3. The next one goes to the left forever. So I would use negative infinity. And on the right, it goes to the number 1. So I would put a bracket at 1. Notice I never put a bracket with my infinities. And the reason up above the negative 2 had the parenthesis was because of this open circle right here. If it was a closed circle, it would be a bracket instead of that parenthesis. Okay, the third one, the left, it only goes left to 3. So I would put a parenthesis and put 3 here, but it looks like the arrow pointing to the right goes on to infinity. So I would put 3 comma infinity. The one underneath, it looks like it goes to the left forever and to the right forever. So one way to say that is negative infinity, comma, infinity. The way I like to say it is it includes all real numbers, and there's a symbol for that, and it looks like this. It's like an R, but with 2 lines for the up and down instead of just 1. It's got like 2 backs instead of just 1 back. That means all real numbers. That's the same thing as writing negative infinity to infinity. So these problems below, the domain for this first example, remember the domain is my left and my right. So how far to the left of this graph does it go? Well, if this keeps going up and to the left, it's going to continue doing that forever and ever and ever. So my domain, it goes to the left until it gets to, well, forever, right? So negative infinity. Going to the right, it does the same thing. It goes to the right forever. And so I would put negative infinity to infinity as my domain. I usually put a D in front for domain. The range is the up and the down. Now this one's a little bit different because my function doesn't go down forever. My function only goes down until it gets to negative 3. So instead of putting a negative infinity right here, my function goes down to negative 3, but it does go up forever. These arrows mean that my function is going to keep going up, so I would put an infinity there for my range. Okay, the second example, domain, it goes to the left forever, it goes to the right forever. I'm going to give you a hint. The domain of a parabola is always negative infinity to positive infinity. That is always the domain. They go left and right forever. Now the range is what's not always the same. This function, the arrows point down, which mean it's going to go down forever. So my range would be negative infinity, and then it goes up until it hits 0. But it never goes above 0, so I would put 0 in a bracket for my range. Okay, the third one, another parabola, which means my domain is all real numbers. So I'm going to use my fancy R to label the domain. Now the range up and down, the range goes down to -4, but it includes -4, so I should use a bracket, huh? So it goes down to -4 and it goes up forever. All right, so the homework. It is going to give you a bunch of quadratic functions, and it's going to ask you, first of all, the first 6, it just wants to know what's the vertex. So how far to the left or right, how far up and down does that function shift? So you're going to use the h and the k. Right here, you're going to use the h and the k value to get the vertex on those first couple of problems. Then it wants you to graph 3 of them, and then it wants you to write the domain and range of each of those. And then the last couple of problems are a little bit more challenging because it gives you the function and it wants you to come up with the equation for that function. So it gives you the picture of the graph and you've got to come up with the equation that would match that picture. Come see me if you have any problems.